Here comes that homework video that I promised you. Clearly very casual Linda here. And I have my iPad hooked up. I jotted down some examples in order to do like a quick, for lack of a better phrase, mini lecture. And hoping this will be helpful. If you have questions, like you actually watch this and then you have questions, send me a message and I will clarify the best way I can. Some of this is going to seem redundant, but yeah, so there you go. All righty, let's do this. Okay, so you've seen me do this in class before. What I've done is I have hooked up my iPad, got my little pencil here. Now I looked over at the assignment and I picked a few different topics. One of them being where they have you add or subtract stuff. So one of the first ones I noted was add the following fractions, then reduce if needed. So how you would do this would be, say that the fractions were 2/7, and then it says plus 4/7. This one is super duper duper simple because this denominator is a 7 and this denominator is a 7. Since they are exactly the same thing, you are just simply going to go straight across. You're going to keep your 7 for your denominator. So literally all you're doing is, what is 2 plus 4? 2 plus 4, 6. That's your answer. 6/7, you cannot simplify. So that's all that is. So that is very simple addition. Now, of course, it's not going to stay at such simple addition. Now, it's going to want you to do some other stuff. You are going to have word problems. I am not going to write the whole word problem down because you have seen me try to do that in class. It takes me forever and it's not the neatest. So I'm just going to read it and I'm going to write down numbers as I come to them. So Johnny pours 9 5/14 yard of cement for a new sidewalk. Another sidewalk takes 6 7/8 yards. How much more cement is needed for the larger sidewalk? Well, this is the larger sidewalk. So what it's asking is for you to just subtract. Since you are just subtracting, you would think this wouldn't be very difficult. However, notice you have a 14 here and you have an 8 here. You can't just simply subtract these two. You have to have the same denominator. So now you have to figure out what would the right denominator be. This ties into the whole least common multiples. And this is where I said it's going to be a little bit redundant from the class. I showed you in class how I do my thing, where I write like a million things down. That's literally what we're about to do. I'm going to start with the number 14 because it's a big number. And then I'm going to say, let's see, 14, and then I add 14, and that gives me 28. So remember how I did that? 1 14 is 1, 2 14s is 28. Then I'm going to do 14 again, and that will give me 42, and then 14 gives me 56, 14 gives me, and that would be what, 70, right? Okay, so 3, 4, 5. And now again, I could have just used a calculator and done each of these. I put them off to the side to help myself. Now, I know it's not going to be 70 because you can't do 8 into 70, but I thought going for 5 was helpful. So now I am going to do the same thing with the number 6. I mean, the number 8. Where did I get the 6 from, right? So I'm going to do the same thing with this one, the number 8. I'm going to use green this time. So now I'm going to do 8. We have 8 and 8 is 16. And then we have 8 is 24. And then another 8 is 36. And then another 8 is Did I do that right? I miscounted something, didn't I? 8 and 8 is 16, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, 25, 26, 27, 28, 29, 30, 31, 32. That should be a 32. That's where I messed up. There we go. See, always double check yourself. And if you saw what I was doing with my fingers, because I am a finger counter. So it's 24, 25, 26, 27, 28, 29, 30, 31, 32. So it's 32. 32 plus 8, I know that is 40. 40 plus 8 will be 48. 48, 49, 50, 51, 52, 53, 54, 55, 56. Hey, guess what? 56. I say, hey, guess what? Because this is 56. This is 56. So our least common multiple is 56. Now, my eyeball. Remember, this was 1, this was 2, this was 3, this was 4, 5, 6, and 7. So that was 7 for that one and 4 for this one. The reason I'm pointing that out is for this part, for our denominators. Now we know we want our denominator to be 56. So we're going to say 9 and then 56 minus and then 6 and then 56. Okay, now bear with me. I do this in a couple of different steps. Yes, just like all the other things, there are other ways to do this. This way might take you a while, but you will then understand what you're doing in every single step. And that's why I show you this way. So now, 9, that was the one that had the 14. So we look at our 14s right here. So it took 4 of them to make the 56. And before, we had a 5. So I'm going to say 5 times 4. This one had a 7, so 7 times. And, oh, look at that. It also took 7. So it's going to be just 7 times 7, right? There we go. I know it looks crazy. But now I do my next step where I put them all together. So now this will be 9 and 5 times 4 equals 20 over 56 minus 6, and that is 49 over 56. Well, and this really is the reason I picked this problem to show you. If you look at this, 20 is smaller than 49, so you can't just simply take everything out. If you remember when we practiced with the subtraction and we did what I call borrowing, you have to do that here too. So now you have to borrow from the number 9 to make the fraction larger. In order to do that, you need to take 56. So we are now, I'm going to do this in blue. It will now be 8 and then say 20 plus 56. So that would be 76. So 76 over 56. Okay, see how that works? We took 1 away from here and then we added it here. And since the denominator is 56, we had to add 56. Okay, now we do minus 6 and 49 over 56. Well, 8 minus 6 equals 2. And then, I meant for that to be red. Come on. We're going to use these two now. So now you say 76 minus 49. Cross that out. And then 9, 10, 11, 12, 13, 14, 15, 16. That will be 7. And then 4, 5, 6, 2. So that will give us a 27 over 56. So our final answer should be 2 and 27 over 56. So this is our final answer. That is how much more cement needed for the larger sidewalk. Yes, I know this was a whole lot. Totally why I wanted to make sure to work this out for you. Okay. I am now going to erase all that. Dum, 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 dum. And just, whoa, what did I do? That is not what I meant to do. No, go away. Go away. Oops, right? Apparently I just went a little too crazy on my erasing. All right. So now, here's another thing I saw that I know we have not talked about. This versus this. Okay. You're going to be asked about this. We have greater than, equals, less than. You will have like a number. So say that you have 8 greater than 7. I say greater than because, and I am not kidding, I used to do this. It's my alligator. My alligator always eats the bigger number. So if it's facing this way, that is called greater than. So this would be greater than. So greater than. This would be less than. So the open part always goes to the bigger number. Yeah, that's pretty much, I really like my little alligator though, isn't he cute? And I am not kidding. When I was doing learning support, I literally drew every one of these as an alligator because I would get confused thinking it's pointing to the one number. So I had to constantly remind myself my alligator's eating the big number. So there you go. That is the difference between greater than and less than. If you see, let's see, there are various ways that this can be done. It can be asking you just, is this greater than or less than? If that is all it asks, then you say that is greater than, because we read from left to right. So that's how you're supposed to look at it. Now, if you see a question like, you have to decide, or shall we say, and if it's asking what you want, that means you have to decide this one would be greater than because it eats the 7. This one, you would do that because it's going to eat the 9. So that's all there is for that one. So hopefully that helped. Now, I talked about least common multiples when I was talking about that denominator. So I'm going to show you a couple of much smaller ones to look at. So I am going to say 8 and 12 and 3 and 4. We are going to look at the least common multiples for these. You already know what you're going to do. I'm going to start right off and say 8 plus 8 equals 16. Guess what? That's higher than 12. So we know we're going to have to do more. So 8. So 16 plus 8 is 24. Oh, 24. I guarantee you it's going to be this. The reason I know that is because 12 and 12 equals 24. Bam. So that means the least common multiple for this one is 24. So least common multiple just means the lowest possible number that both of those numbers can go into. So that was relatively painless. Then we have, and I have another one that I just thought of I'm going to use too. Then we have our 3 and 4. Well, easiest way for this, because it's 3, 4, they're right next to each other, I would just do 3 times 4 equals 12. That's going to be your least common multiple. If you don't believe me, check it out. 3 plus 3 equals 6, plus 3 equals 9, plus 3 equals 12. 4 plus 4 equals 8. 8 plus 4 equals 12. There you go. Least common multiple, 12. Okay, now one more, because it's another one where it's just you have to use a tiny bit of logic. Speaking of logic, ever wonder why when I'm erasing, sometimes it's a huge circle that erases a lot, and other times it's this teeny tiny one that takes me forever? Crazy. Okay, I am going to do 2 and 48. Huge difference, huge. But check this out. That ends with an 8. That's an even number. We've already learned with our divisibility rules, if it's even, it's divisible by 2. So your least common multiple is 48. Because you can't be less than 48 and include 48, but you know 2 goes into 48. So there you go. So that's what I meant by sometimes you just use your logic. Yeah, it's still just pixel, so. Okay, we are almost done. I have just a couple more things to show you. Now, there's also going to be things like where they give you different fractions, like we're going to say 1/2, 7/8, 2/3, 3/4, and 5/7. And then they're going to ask you to put these in order from smallest to largest. So here's the fun thing. You can visualize these. You can convert them all so they all are exactly the same numbers, like the same denominators. Or you can use a calculator. We have a variety of ways to do this. First way, you already saw ones where it drew things out. So like when we had this, and then one thing was filled out, you know, that's the 1/2. And let's see if I can do this right off the bat. If I do that, that would be, yeah, there we go. That's 8. So if I go 1, 2, 3, 4, 5, 6, 7, that's my 7/8. Then I can do 2/3. And then we have our, I said 3/4. And yes, I know I'm going on and on and on here, but I kind of like the visualizing thing. Yeah, we're going to change this to an 8 because I don't know how to do an easy drawing 7. Okay, so there we go. I'm cheating. I'm doing that. There we go. So now I'm going to do another one of 8. Glump, glump, and glump. And then I'm going to do 5 of them. So we're going to color in 1, 2, 3, 4, 5. All right, so I put them in the same order. If you look at this, you should be able to tell that this one looks largest. And this one, I believe, would be, no. Look at that. I just caught myself. I honestly think this one might be the smallest. Because this is more than 1/2, more than 1/2, more than 1/2, more than 1/2. So 1/2 is going to be our smallest. And you just work from there. The one that's going to stump you probably is going to be with these next 3. So what we can do, I should write this on here too, right? 1/2 and then 7/8 and then 2/3 and then 3/4 and then 5/8. All right, so what I can do here is find the least common multiple and convert every one of them. That would honestly be the smartest way to go about it. So that's what I'm about to do. So let's see, we need to find the least common multiple for 2, 8, 3, and 4. Well, we already know 3 does not go into 8 because it would be 3, 6, 9. But we do know 12. Does 8 go into 12? No, because 8 and 8 is 16. So we have to keep going up. So let's see, we've got our 8s again. We've got 8 and 8 is 16, and then another 8 is 24. Let's think that through. 24 is a multiple of 3, it's a multiple of 2, it's a multiple of 8. Does 4 go into 24? Yes, it does. So now we can convert. Our denominator is going to be a 24. So this one, half of 24, this one is going to be 12 over 24 because 2 goes into 24 2 times, right? 2 goes into 24 12 times. I knew I missed it up. I had to like rewind in my head. Okay, so now 8. 8 goes into 24. Well, we've got 1, 2, 3, 3 times. So 8, well, I showed you how to do this a moment ago, and I'm going to use my calculator here. Well, this is what I mean by use my calculator here, just to make darn sure. So we are going to say, wait, I just did that wrong, didn't I? Yeah, I did. Okay, so let's see. We're going to do 8 goes into 24. Yeah, 8 goes into 24 3 times. I swear I keep messing it up. So 7 times 3, so we should be 21 over 24. Yeah, just double checking my math, which, you know, is a good thing to do. So like I just showed you before, we are going to say 7 times 3 over 24. And so that is 21 over 24. I'm going to do the same thing here. Well, if 8 goes into 24 3 times, then we know 3 goes into 24 8 times, right? So we are going to do 2 times 8 over 24, and that would be 16 over 24. And then 4 goes into 24. Well, let's see. We've got 4 and 4 is 8. 4 is 12. 4 is 16. 4 is 20. And then 4 is 24. So that would be 1, 2, 3, 4, 5, and 6. So it'll be 6 times. So now we go 6 times 3, because this is my 3, over 24. 6 times 3 is 18 over 24. Well, this one, it's 8 again. We already know that, so we already know it's 3. So this one will be 5 times 3 over 8, which is 15 over 8. I know it's all kinds of crazy, but now we know we can just look at our top numbers. So we know that this was the smallest, like we already said. So this is number 1 for smallest, and then this one. So that would be, oh, that should say 24, sorry. Ignore that I forgot to change the denominator there. So 5/8 would be number 2, and then 16. So 2/3 would be number 3, and then 18, that would be number 4, and then this one would be number 5. So then once you have it figured out, then you can just rewrite them all. So you don't need the visualization. I just kind of like the visualization, but picking the common denominator is what you need to do. And learning to pick your common denominator, i.e. your least common multiple, is how you actually solve a whole lot of things. So let me get this crazy mess erased so then I can show you just a couple more things, and then we'll be good. I swear my quick little videos are always way longer than anticipated, and I'm sorry. Okay, here we go. If you have something like 4 over 5 It's greater than 11 over 12. Is that true? Is 4/5 greater than 11 over 12? Well, again, you can try to visualize it, or you can do the common denominator thing. So let's just do the common denominator thing. We need, again, the least common multiple. We have just 2 here, so you can try to pick the smallest one possible, or since we don't have to simplify or anything because they're already simplified, you can literally just do this. What is 5 times 12? Well, I guess I shouldn't use the calculator. I was going to do that, but I was like, nope, let's do this. We're going to do 12 times 5. 5 times 2 equals 10. 5 times 1 is 5. Plus 1 is 6. So that would be 60. So I'm going to say 60 and 60. Now, 5 goes into 60 12 times. So this is going to be 4 times 12. And then 12 is going to be 5 times. So 5 times 11. So that will give me 12 times 4. So that's 4 times 2 is 8, and then 4. So that will be 48. Whoa! Don't you hate when I do that? I pressed a button. Look at that. It smeared it all the way down too. 48 over 60. And then 5 times 11 is going to be 55 over 60. Now, if you've done that, all you're having to look at are these 2 numbers. Guess what? This? No, that does not work because 48 is not larger, is not greater than 55. It would have to be this. So when you have just 2 and you're not having to simplify, I just multiply the 2 together and I'm done with it. Okay. Whew, almost done. There were only 2 others. Here we go. Only 2 others I was going to do. We have 8 over 39 plus 16 over 91. These are crazy. Crazy, 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 right? Well, let's see what you want to do here. We can pick the lowest common denominator, or we can do what I just did a moment ago and do 91 times 39. 9 times 1 equals 9. 9 times 9 equals 81. I put a dash here. 3 times 1 equals 3. 3 times 9 equals 27. And then that's adding 1 plus 3 equals 4. 8 times 7 equals 15. Carry the 1, and then that's 3. Is this insane? Yes, it is. But if you're using a calculator, it's really not that bad. So if I choose to go this route, you're going to have to do a lot of simplification. And I think that's why they give it to you that big. So if we go this route, then I'm going to have to say 8 times 91 over 3, 5, 4, 9 plus 16 times 39 over 3, 5, 4, 9, and then I solve. That's a little crazy. So I don't think you want to do that. So let's do, why did I erase the top one? I don't know. Still going to be the same problem, but for some reason I erased that. So let me do this and then put it back. So it was what? 8 over 39. So now we really just want to find, again, a least common multiple. Well, let's start with 39. We're going to say 39 and 39. Well, 9 plus 9 is 18. Carry the 1, and that's 6, 7. So that's 78. Another 39, and that would be what? 17. And that is 11, right? 7, 8, 9, 10, 11. And then another 39. And so that would be 16, 3, 4, 5, 156. I'm going to do the 91s real quick, just in case. So that would be 182. Oh, yeah, we have to keep going. So 39. So let's see, 9, that would be 15. That is 8, 9. Let's do another 39. This is taking forever, isn't it? 9, and that would be 14, and that would be 13, and that would be 2. So now I'm going to come over here and do another 91. See, still not there, so that's 17, 273. So another 39, 9, 10, 11, 12. Wait, 13, yeah, so 3. Oh, wait. Look at there. We now have 273. So this is 1, this is 2, this is 3. So that we know 91 times 3 equals 273. So that's the 91. Okay, so that means this one's going to be the times 3. Now this one, we've got 1, 2, 3, 4, 5, 6, and 7. So that means 39 times 7 equals 273. So this one's going to be times 7. Now let me erase these, mainly because I just made a big old mess. And look at that, it's got the nice big circle again. I think we're probably going to stop with this one, maybe. No, I do have one more that is not too terribly bad. Okay, so now we just have to, I just erased everything. I forgot what it was, 273. So I'm going to write 273 here so I don't forget again. Okay, so now, whew, good thing I had that undo button there, right? Okay, so now what is 8 times 7? We're going to say 273 plus 273. So now I can get rid of that so it's not distracting. There we go. So now 8 times 7. 8 times 7 should be what? 56, right? I am going to do this again. 8 times 7. Yeah, 56. 56. Now 16 times 3, 48. So now I just have to add 56 plus 48. So 56 plus 48 equals 104 over 273. There you go. Now, can it simplify is the big question there, right? If I had my better calculator here, I'd be able to tell you that for sure. I don't see it right off the bat. 3, 10, 12. I think that would probably hopefully be one of their answer choices. If not, then we'll talk more about simplifying. I just wanted to get here. And my very quick little thing has turned into a very long thing. So let me do this very last one, because I think I covered everything else I planned. I've got this. I have this whole piece of paper over here to make sure I covered enough things. How many more times can I say things, right? Okay, last one. 11 over 14 minus 2 over 7. Again, first thing to note, we have different denominators. Can't do that. But notice, if you will, when we've done our thing, writing down the side, 7 plus 7 equals 14. We already have our least common denominator of 14. So that means 11 over 14 stays exactly the same because you don't have to change it. But we do have to make this to a 14. 7 goes into 14 2 times, and it already has a 2 up there. So that means this is 11 over 14 minus 4 over 14. And now you just have to subtract this part. So now 11 minus 4, well, I count up. I say 4, 5, 6, 7, 8, 9, 10, 11. That's 7. So that means this would be 7 over 14. Isn't that interesting? If you have 7 over 14, I don't know why I keep doing that something funky with that 1. If you have 7 over 14, that's going to simplify to what? 1/2. So that would mean your answer of 11 over 14 minus 2 over 7, that actually equals 1/2. Crazy, right? So there you go. I think that's it. I'm going to erase all this so it's not there the next time I use it, because I tutor the next 2 days and one of them we're doing nothing but math. And I use this like a lot. Okay, so I'm going to stop the share and close my stuff and say, I hope this wasn't too terribly long. It kept getting darker. I think a storm's coming and I'm hoping to maybe get a walk before it starts storming. I don't know. I feel like I rattled on a lot, but I do that in most of my lessons anyway. And this was way longer than I meant for it to be. So hopefully I didn't bore you and hopefully it made sense. And please, 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 please send me questions if you have any. And I guess other than that, I'll see you on Saturday.